Howdy, this is Jeff Bowen here with another mathematical video. Today we're going to be reviewing a word problem having to do with probability. Alright, I'm going to read the word problem here and we're going to take some notes on the important information and see what we can find out. To begin, first off we have a bag. So let's draw a bag here. Let's see, we've got a bag. Okay, give it a little tassel. There we go. This is our bag and it contains marbles. This bag contains the following. It contains 6 red, 1, 2, 3, 4, 5, 6, 4 blue, 1, 2, 3, 4, and 8 green marbles. 1, 2, 3, 4, 5, 6, 7, 8. Okay. The question. How many marbles of each color should be added so that the total number of marbles is 27, but the chance of randomly selecting a marble of each color remains unchanged? Alright, well let's take a look at this problem as it presents itself, and I encourage you to stop the video here or at any point as I walk through it to sort of get an idea of what's going on. And, I'll walk through this step by step. You can pause at any point if you think that you've got it so you can get the next step down. So, our objective is to increase the number of marbles to 27. And the first thing you might ask yourself is, how many marbles are already in the bag? So how many marbles do I have to add in general? Doesn't matter what color. Well, this is 8, this is 4, and this is 6. 6 and 4, that's 10, that's 18. Right now, this bag already has 18 marbles. Okay? And we need to increase to 27. So in some way, well, you can think this is 27 minus 8. That's 9. We're going to be adding 9 marbles. Okay? And what I've seen a lot of people try first is they'll say, okay, I'll add 3 of each color and see what happens. And that's an interesting step. You can try that. In fact, I encourage you to try that and see what happens. But we need to add marbles such that the probability does not change for each selection. All right. Well, what is the probability of selecting, let's say, a green marble? All right, you reach in this bag, you shuffle your fingers around a little bit, and you pull out 1 marble. What's the chance that you're going to get a green one? Well, there are 8 marbles that are green out of a total of 18, so that's a 8 out of 18 chance for green. Right? And likewise out of blue, there's a 4 marbles in here that are blue, so we have a 4 out of 18 chance. 4 marbles out of 18 in total are blue. So if we randomly choose one, we have a 4 out of 18 chance to get blue marble. And lastly, for red. For red, 1, 2, 3, 4, 5, 6. 6 out of 18. 6 18ths of a chance. Okay. So we can leave these as is. We can leave these as 18ths. We can also talk about them as percentages. And the way we would do that is we would divide the numbers out and we would multiply by 100 to come up with what the percent chance is. Let's actually do that real quick. Let's start with 6 18ths. All right, this is asking how many times does 18 go into the number 6? All right, it doesn't, so we have to add a decimal point. Put a 0 here. Now how many times does 18 go into 60? Well, 18 is close to 20. 20 times 3 would be 60. I'm going to say 3 for now. 3 times 18? Well, that would be 6 less than 60, which would be 54. 3 times 18 is 54. That leaves us a remainder of 6. We're going to bring a 0 over here and bring it down. And how many times does 18 go into 60? Well, that's actually 3 again, and so we see here that this is going to be 0.3 repeating, because if we do this, 3 times 18 is 54, 60 minus 54 is 6, and so on and so forth. Add another 0, this is just going to go on forever, 0.3 repeating. which makes sense actually because 6 over 18 is actually just 1/3. There's a 33% chance of reaching into this bag and pulling out a red marble. All right, so this here we would convert into a percentage, 0.33, by multiplying by 100 at this point. So 0.33 times 100. Move the decimal point over 2 spaces since we're multiplying by 100 with 2 zeros, so we get 33. 0.33 repeating, percent chance. We can do that with each of the following numbers as well. All right, and after we do the math out, which I encourage you to do, you'll find the following. 4/18 will leave us with a 22% chance of 22.22% actually. This is repeating. And 8/18 will leave us with a 44.44% chance. 44.44% chance repeating. And there's actually, this is repeating as well. All right. In total, after you can double check your work at this point by adding all these numbers up, just in case there were any problems with your long division. You could add all these numbers up. Put a little 0.22 repeating in there. And if you add all these up, what do you get? Well, 33 plus 22 plus 44. That's going to give you 99, and then add up the 0.3 repeatings, the 0.2 repeatings, and the 0.4 repeatings. This will give you 100%. And of course, you have a 100% chance of selecting a marble in general if you pull one out of the bag. But that's not what the question is asking us. It didn't ask us to convert these all into percentages. We're just doing that to sort of get an idea of what's going on here. What we're actually being asked to do is the following. We're asking, what do we have to do in order to get it so that if we add 9 marbles to the bag, these percentages remain the same? And we're going to do that next. All right, so let's talk about how to solve this problem. Let's do it step by step. Let's start with the 6 out of 18 of the marbles in the bag are red. All right, and we want to increase that 6 to some number such that the total number of marbles in the bag are 27, but the percent chance of getting a red marble remains the same. So let's start with 6 out of 18 of the marbles in the bag. And we want to increase the total number of marbles in the bag, which is this denominator right here, to 27. And we want to get some number in this numerator, let's call it x, such that this number, whatever it is, will be the same as this percentage over here. So we want this 33% to be equal to this 33%. So whatever number fits in here that makes some number out of 27 equal to 33.33 repeating percent, that's the number we want. That's how many marbles need to be in the bag. Okay, how are we going to figure this out? Well, a nice trick we might know is actually cross multiplication. And cross multiplication says that if we have an equality like this, such that a fraction is equal to another fraction, then we can cross multiply and then divide. All right, so this is going to be 6 times 27. 6 times 27, which is 162, is going to be equal to 18 times x. 18 times x. And then we just finish this off by dividing by this number over here, 18. So divide both sides by 18. 162 divided by 18 gives us 9. All right, how many of you guessed that? How many of you guessed that if we added three marbles, 3 red marbles to this bag for a total of 9 red marbles, that the percentage would be the same? Well, that's the key here. All right, but that's only for the red marbles. We also need to add a certain amount of blue marbles and a certain amount of green marbles. Do you think that the number is going to be the same for each of the colors? Let's find out. Let's use that same strategy we just talked about. All right, this time we have a total of 4 out of 18 of the marbles that are blue. And we want to increase the total again to 27 marbles in the bag. How many of them? How many of them do there need to be? We're going to call that x. That's a variable. We're going to call it an unknown. You could write a question mark here. You could write a square. You could write a triangle. You could put any symbol you want here just to represent this unknown that we're trying to figure out. What did we do over here to solve this? Cross multiplication. Let's try it again. All right. 4 times 27 is 108. X times 18 is 18x. All right. Divide both sides by 18. What do we get? 108 divided by 18. You know what I'll do? I know it's going to be 6. X is going to be 6, but let's do the long division out on that. Let's practice our long division skills, all right? So this is 108 divided by 18. All right? So how many times? Well, actually, this isn't a really good problem for long division because you actually just have to kind of intrinsically know what the answer is going to be, because 18 doesn't go into 10. And so you're going to have to try and just figure out how many times does 18 go to 108. And the answer is 6. All right, 6 times 18 is exactly 108. That's just zero. Sorry about that. I guess that's not a good example of something where you need to use cross multiplication. All right, so we need a total of 6 blue marbles in this bag. So we need to add 2. Let me write this here. We have to add plus 2 blue marbles. And for the red ones, we have to add plus 3. Now there are 2 ways to find out how many green marbles we need to add. The first way is as such. Well, we know we had to add 9 marbles in total, and we've already added 5. So no matter what, we're going to have to add 4 green marbles. We have no other choice. That's the first way to solve. But we can also solve using this method again, and if we do this method, we should come up with 4. There's no other possibility here. We have to come up with the number 4, otherwise this problem won't hold true. So let's figure it out. We don't want to change the probability. We have 8 out of 18 marbles that are green, which is going to be equal to, put a question mark here this time, question mark, it could be x, it could be anything, it's a variable, question mark out of 27, because that's the total number of marbles that we're increasing this bag to. Same thing as before, cross multiplication, and then division. 8 times 27, 18 times question mark, that gives us 8 times 27, 216, equal to 18 times question mark, which is just 18 times question mark. Undo this multiplication here with division, divide by 18. All right, this is a problem that we might be able to do long division with. Let's see if this one works out. 216 divided by 18. How many times does 18 go into 2? It doesn't. How many times does 18 go into 21? Once. 1 times 18 is 18. 3. Bring down the 6. How many times does 18 go into 36? Twice. All right. 12. 2 times 18 is 36. 36 minus 36 is 0. We're left with 12. Hey, we need a total of 12 marbles in this bag. And that would be increasing 8 by 4 would give us 12. So that works. So this works. Everything works out. There we have it. In order for the probabilities to not change, to get to 27 marbles, we need to add 3 marbles that are red, 2 marbles that are blue, and 4 marbles that are green. All right, thank you very much. I hope you enjoyed the video. Have a great mathematical day.